Hello there, and welcome back to the Sleepy Science Channel. Tonight, we're drifting into one of the greatest mysteries in all of science. Not a distant galaxy, not a black hole, not even the beginning of the universe. Instead, we're exploring something that appears to be everywhere and yet has never been directly seen. Dark matter. As you settle in and get comfortable, allow your breathing to slow. Let your thoughts become lighter. There is nowhere you need to be. Nothing you need to solve. Tonight, we're simply following a mystery through the quiet darkness of the cosmos. A mystery that surrounds every galaxy, flows through every cluster of stars, and may even be passing through your body at this very moment. Scientists believe dark matter makes up most of the matter in the universe. Yet no telescope has ever captured an image of it. No human has ever held a piece of it. No laboratory has definitively detected it. And still, its presence appears unavoidable. Again and again, across the universe, something invisible seems to be shaping everything we see. So tonight, we'll gently explore the strange clues that led scientists toward this hidden substance. We'll wander through galaxies, cosmic webs, ancient light, and invisible structures stretching across billions of light years. Some facts may surprise you. Others may simply leave you with a quiet sense of wonder. And perhaps, somewhere along the way, you'll drift peacefully into sleep. Now, let's begin. Dark matter was discovered because galaxies refused to behave. In the early 20th century, astronomers expected galaxies to follow familiar rules. Just as planets orbit the sun according to gravity, stars should orbit the centers of galaxies according to the amount of visible matter present. The logic seems straightforward. The farther a star is from the galactic center, the slower it should move. Much like the outer planets move more slowly around the sun. But when astronomers began measuring these motions, something strange appeared. Stars near the outer edges of galaxies were moving far faster than expected. According to calculations, many of them should have escaped into space long ago. Yet they remained exactly where they were. Something invisible appeared to be holding them in place. Something massive, something unseen. At first, many scientists assumed there must be an error. Perhaps the measurements were wrong. Perhaps the galaxies were unusual. But as more observations accumulated, the pattern remained. Everywhere they looked, galaxies behaved as though they contained far more matter than anyone could see. The universe seemed to be hiding something. Dark matter does not glow. Stars shine because nuclear fusion produces enormous amounts of energy. Planets reflect sunlight. Nebulae glow from energized gases. Even black holes can become visible when surrounding matter heats up. Dark matter does none of these things. It does not emit light. It does not reflect light. It does not absorb light in any detectable way. In fact, the reason it is called dark matter is surprisingly simple. It appears dark, not dark in color, dark in visibility, invisible to every form of electromagnetic radiation we have tested. If you placed a cloud of dark matter beside a bright star, the star would shine brilliantly. The dark matter would remain completely hidden, and yet it would still possess gravity, still possess mass, still influence the universe around it. It would simply do so silently. The Milky Way may contain far more dark matter than ordinary matter. When we look at the night sky, it feels full. Thousands of stars, clouds of gas, planets, nebulae. Yet everything visible inside our galaxy appears to account for only a small fraction of its total mass. Astronomers estimate that most of the Milky Way's matter exists in an enormous invisible halo surrounding the galaxy. This halo extends far beyond the visible spiral arms, far beyond the bright regions we can photograph. Its gravity influences the motions of stars across the galaxy. Without it, the Milky Way might not remain stable. The galaxy we call home may be floating inside a vast sphere of invisible matter. A hidden structure far larger than the galaxy itself. Dark matter helped build the universe. After the Big Bang, the universe was remarkably smooth. Matter was spread almost evenly in every direction. Yet today, the cosmos contains galaxies, clusters, superclusters, and enormous cosmic filaments. Somehow, tiny variations grew into immense structures. Scientists believe dark matter played a crucial role. Unlike ordinary matter, dark matter was not slowed by interactions with light. It could begin clumping together very early. These invisible clumps acted like gravitational seeds. Ordinary matter gradually fell toward them. Stars formed, galaxies emerged, clusters assembled. Over billions of years, the invisible framework built by dark matter helped shape the visible universe. In a sense, galaxies may be decorations placed upon an invisible scaffold. A cosmic architecture hidden beneath reality. Dark matter may be passing through you right now. This sounds like science fiction. Yet according to current models, Earth moves continuously through a vast halo of dark matter. If dark matter consists of particles, countless numbers may flow through our planet every second. Through buildings, through mountains, through oceans, through your body. Yet because dark matter interacts so weakly with ordinary matter, you never notice. It leaves no sensation, no sound, no warmth, no visible trace. The particles simply continue their journey, passing silently through everything. The room around you may be filled with dark matter, and you would never know. Scientists have spent decades trying to detect it directly. If dark matter is real, what exactly is it? That question has inspired some of the most sensitive experiments ever built. Deep underground laboratories, massive detectors filled with liquid xenon, ultra-cold instruments protected from cosmic radiation. Researchers hope that occasionally a dark matter particle might collide with ordinary matter. A tiny interaction, a faint signal, a brief flash, enough to reveal its presence. So far, the search continues. Many promising hints have appeared. None have been confirmed. Dark matter remains elusive, like a shadow that leaves footprints but never reveals its face. Galaxies rotate almost like solid objects. Imagine a spinning merry-go-round. The outer edge moves faster than the center. Something similar should happen in galaxies. Instead, many galaxies rotate in a surprisingly uniform way. Stars far from the center move almost as quickly as stars much closer in. This observation became one of the strongest pieces of evidence for dark matter. The visible stars simply do not contain enough mass to explain these motions. An enormous invisible component appears necessary. Something extending far beyond the visible galaxy. Something creating additional gravity. Something unseen. The evidence appears again and again. Across countless galaxies. Across billions of light years. Dark matter seems to leave the same signature wherever scientists look. The universe may be woven together by invisible filaments. On the largest scales imaginable, galaxies are not scattered randomly. They gather along enormous cosmic strands. Filaments stretching hundreds of millions of light years. Between them lie enormous voids. Regions containing relatively little matter. This pattern resembles a giant web. Scientists believe dark matter played a central role in creating it. The invisible matter formed large structures first. Ordinary matter followed. Galaxies appeared along these gravitational pathways. Today, the universe resembles a vast network. A cosmic web stretching beyond imagination. And much of that web may be built from something we still cannot see. The story of dark matter is also the story of humility. Every major scientific revolution reminds humanity of something important. Reality is often stranger than our assumptions. We once believed Earth sat at the center of everything. Later, we discovered it orbits the Sun. We believed our galaxy might be the entire universe. Then we found billions more. Now we face another possibility. Perhaps most matter in existence is invisible. Perhaps everything familiar represents only a small fraction of reality. The stars above us, the planets, the oceans, the mountains, even ourselves. Together, we may represent only a tiny island of ordinary matter drifting within a far larger invisible cosmos. And that thought is strangely beautiful, because it reminds us that mystery still exists. The universe has not revealed all its secrets. Not yet, not even close. And perhaps that's part of what makes it so fascinating. As the night continues and your thoughts grow quieter, imagine the Milky Way floating through darkness. Billions of stars turning slowly around an invisible center. Invisible matter stretching far beyond the bright spiral arms. Galaxies gathering into clusters. Clusters connecting through hidden bridges. A vast cosmic web spanning the universe. All shaped by something we cannot see. Something we barely understand, yet something that may be everywhere. Dark matter remains one of science's greatest mysteries. And tonight, perhaps it can remain simply that. A mystery. A quiet companion drifting through the darkness alongside the stars. And as the universe continues its slow, silent dance beyond the night sky, you can let your thoughts drift as well. Further, slower, softer, until curiosity becomes calm, and calm becomes sleep. One of the strangest things about dark matter is that we know more about what it isn't than what it is. It isn't made of ordinary atoms. Not the atoms that form stars. Not the atoms that form planets. Not the atoms that form your body. Scientists have tested this idea repeatedly. If dark matter were made of ordinary matter hiding somewhere in space, we would expect to see certain signatures. We would see light interacting with it. We would see clouds of gas. We would detect hidden stars. Yet observation after observation suggests otherwise. Dark matter appears fundamentally different. A completely separate ingredient of reality. Almost like the universe contains two parallel forms of matter. One visible, one invisible, one familiar, one mysterious, and together they shape everything around us. Dark matter creates gravitational lenses in space. Gravity does something remarkable. It bends light. According to Einstein's theory of relativity, massive objects curve space itself. When light passes nearby, its path bends. This effect is called gravitational lensing. Astronomers often observe distant galaxies appearing distorted, stretched, or multiplied. Sometimes a single galaxy appears as several images. Sometimes entire rings of light form around massive objects. These distortions reveal the presence of gravity. And often, the visible matter alone cannot account for the amount of bending observed. Something extra appears to be present. Something invisible. By studying these cosmic distortions, scientists can actually create maps of dark matter. Not because they see it directly, but because they see what its gravity does to light. In a strange way, dark matter becomes visible through its effects. Like watching wind by observing moving leaves. The largest dark matter structures are unimaginably vast. Human minds evolved to understand forests, mountains, rivers, not structures stretching across billions of light years. Yet the universe contains exactly that. Computer simulations show enormous dark matter networks spanning the observable cosmos. Gigantic filaments connecting clusters of galaxies. Massive invisible highways stretching through space. Some structures are so large that light requires hundreds of millions of years to cross them. Others stretch for billions. If dark matter could suddenly become visible, the night sky might look completely different. Instead of isolated galaxies floating in darkness, we might see glowing webs connecting everything together. A vast hidden framework underlying the entire universe. Dark matter may have existed before the first stars. Long before galaxies formed. Long before planets appeared. Long before Earth existed. Dark matter was likely already present. In the earliest moments after the Big Bang, the universe contained extreme temperatures and unimaginable densities. Ordinary matter remained tightly linked to radiation. Dark matter, however, may have begun forming structures much earlier. Small invisible clumps, tiny concentrations of gravity. Over time these grew larger, eventually attracting ordinary matter. The first stars ignited. The first galaxies emerged. Without dark matter, those early structures may never have formed so quickly. The stars you see tonight may owe their existence to invisible events that happened billions of years before they were born. Some scientists believe dark matter particles are everywhere. Many theories attempt to explain dark matter. One idea proposes particles called WIMPs, weakly interacting massive particles. Another suggests axions. Others propose entirely different particles that have never been observed. Each possibility carries fascinating implications. If dark matter consists of particles, then trillions may pass through every room, every mountain, and every person continuously. The universe could be filled with an invisible sea of particles flowing silently through space. A hidden population sharing the cosmos alongside ordinary matter, existing everywhere, yet remaining almost completely undetectable. It is one of the most unusual ideas in modern science, and yet it remains surprisingly plausible, because the evidence for dark matter itself continues to accumulate. Galaxy clusters revealed one of the biggest clues. In the 1930s, astronomer Fritz Zwicky studied enormous groups of galaxies called clusters. These clusters contained hundreds or even thousands of galaxies bound together by gravity. When Zwicky calculated their motions, he discovered something puzzling. The galaxies moved far too quickly. According to visible matter alone, the clusters should have flown apart. Yet they remained intact. He proposed the existence of missing mass, an invisible substance producing additional gravity. At the time, few people paid attention. The idea seemed strange. Decades later, observations of galaxies revealed exactly the same problem. Once again, invisible mass appeared necessary. What initially seemed like an odd anomaly slowly became one of the most important mysteries in astronomy. Dark matter may outweigh ordinary matter by more than 5 to 1. Think about everything familiar. Every star, every planet, every moon, every cloud, every ocean, every tree, every person. Together, all ordinary matter appears to represent only a small fraction of the universe's total matter content. Current estimates suggest dark matter outweighs ordinary matter by roughly 5 times. If that is true, then most matter in existence is invisible. The universe is not primarily made of stars, not primarily made of planets, not primarily made of anything we can see. Instead, visible reality may be a thin layer floating atop a much larger invisible foundation. A hidden majority shaping the cosmos from behind the scenes. Scientists have created enormous underground dark matter detectors. Searching for dark matter requires extraordinary patience. Many experiments are buried deep underground, beneath mountains, inside abandoned mines, far below Earth's surface. The reason is simple. Researchers want to block interference from cosmic rays and background radiation. Only then can they search for extremely rare events. Inside these facilities sit giant tanks filled with ultra-pure materials. Liquid xenon, liquid argon, sensitive detectors waiting quietly, sometimes for years, waiting for a single possible interaction. A tiny signal, a faint flash. Evidence that dark matter has finally revealed itself. So far, the mystery remains unsolved. But the search continues, patiently, relentlessly, like listening for a whisper in an ocean of silence. Dark matter may surround every galaxy. Galaxies do not appear to float alone. Most seem embedded inside massive dark matter halos. These halos extend far beyond visible stars. Far beyond bright spiral arms, invisible spheres of gravitational influence. When galaxies collide, these halos interact. When galaxies merge, the halos merge as well. In many ways, the visible galaxy may simply be the bright center of a much larger invisible structure. A galaxy's stars occupy only a small portion of its true extent. The rest remains hidden. Dark matter might be the universe's greatest unsolved puzzle. Science has explained many mysteries. Why planets orbit, why stars shine, how galaxies form, how black holes behave, yet dark matter remains stubbornly unresolved. We know it exists, or at least something behaves exactly as if it exists. We can map its effects, measure its gravity, observe its influence, but we still do not know its true nature. And perhaps that uncertainty is part of its appeal. It reminds us that discovery is not finished. The universe remains full of unanswered questions, hidden truths waiting patiently in the darkness. And somewhere, perhaps years from now, or decades, or centuries, someone may finally uncover the answer. Until then, dark matter remains a shadow stretching across the cosmos. Invisible, silent, everywhere, and as the stars continue their slow motion through the night, and galaxies drift across billions of years, the mystery remains, flowing quietly through space, through galaxies, through our world, and perhaps even through the room around you right now. A hidden universe within the visible one, waiting to be understood. There was a moment when dark matter nearly disappeared. Not from the universe, but from science. For a time, some researchers wondered whether dark matter might not exist at all. Perhaps gravity itself behaved differently on cosmic scales. Perhaps the laws we use to describe motion needed adjustment. After all, science has rewritten its rules before. When Newton's laws failed to explain certain observations, Einstein introduced relativity. Maybe another revolution was waiting. Maybe galaxies weren't hiding invisible matter. Maybe gravity was hiding new secrets. This idea inspired alternative theories that modified gravity itself. Some could explain certain galactic motions surprisingly well. Yet as observations improved, the challenge became larger. Dark matter didn't explain just one mystery. It explained many. Galaxy rotations, galaxy clusters, gravitational lensing, the cosmic microwave background, the large-scale structure of the universe. Again and again, invisible matter seemed to fit the evidence more naturally. Today, alternative theories still exist, but dark matter remains the leading explanation. Not because scientists love the idea, but because nature keeps pointing toward it. The bullet cluster became one of the strongest pieces of evidence. Among the countless structures scattered across the universe, one stands out. A system known as the bullet cluster. Two galaxy clusters collided long ago. The aftermath created a remarkable cosmic laboratory. Astronomers observed hot gas crashing together. This gas contains much of the visible matter in the clusters. Using X-ray telescopes, they mapped its location. Then they mapped gravity using gravitational lensing. The results were astonishing. Most of the gravitational mass appeared somewhere else, not where the visible gas was located. Instead, it traveled ahead during the collision, as if an invisible component passed through relatively unaffected. This observation became one of the strongest pieces of evidence supporting dark matter. The gravity appeared physically separated from much of the visible matter, almost as though two different universes briefly revealed themselves. One visible, one invisible, both occupying the same space. Dark matter may be colder than ordinary matter. When scientists describe dark matter as cold, they do not necessarily mean temperature. Instead, they refer to motion. Cold dark matter moves relatively slowly, at least compared to the speed of light. This matters because slow-moving matter can clump together more easily. It forms structures, builds gravitational wells, creates foundations for galaxies. Computer simulations suggest cold dark matter produces a universe remarkably similar to the one we observe. Galaxies emerge, clusters form, cosmic webs appear. The invisible matter acts like cosmic scaffolding, supporting everything else. If dark matter moved too quickly, those structures might never have formed. The universe would look dramatically different. Perhaps emptier, perhaps smoother, perhaps without galaxies at all. Every galaxy you see may owe its existence to the slow motion of invisible particles billions of years ago. Dark matter halos may collide constantly. Galaxies are not stationary islands. They move, merge, collide, grow. Throughout cosmic history, galaxies have repeatedly encountered one another. When this happens, their dark matter halos interact as well. Enormous invisible structures overlap and pass through each other. These collisions unfold over hundreds of millions of years, far longer than human civilizations, far longer than recorded history. The process is so slow that no observer could watch it happen directly. Yet across the universe, countless dark matter halos continue their silent encounters. Invisible giants drifting through the darkness, shaping the future of galaxies. One collision at a time. The universe might contain dark matter cities. Not literal cities, but vast concentrations of invisible matter. Computer simulations reveal something fascinating. Dark matter does not spread evenly. Instead, it forms dense regions. Invisible clumps ranging from enormous halos surrounding galaxies to much smaller structures. Some scientists compare them to cosmic neighborhoods, regions where dark matter gathers in greater abundance. If dark matter could somehow become visible for a single night, the universe might appear crowded with intricate structures. Invisible mountains, invisible rivers, invisible cities of matter, a hidden geography underlying everything we know. The oldest galaxies reveal dark matter's fingerprints. Modern telescopes allow astronomers to see incredibly distant galaxies, so distant that their light began traveling when the universe was very young. These ancient systems provide important clues. Many appear surprisingly mature, surprisingly organized, surprisingly large. Dark matter offers one explanation. Its gravitational influence may have accelerated the formation of early structures, helping galaxies grow more rapidly than ordinary matter alone could achieve. Each ancient galaxy becomes a fossil, a relic from cosmic childhood. And hidden within those fossils are clues pointing toward the invisible matter that helped shape them. Dark matter does not seem interested in ordinary matter. If dark matter interacts with ordinary matter at all, it does so extremely weakly. This is one reason detection proves so difficult. Ordinary matter interacts constantly. Atoms collide, photons scatter, molecules bond, chemical reactions occur everywhere. Dark matter appears different. It mostly ignores ordinary matter. Passing through planets, passing through stars, passing through people, as though none of them exist. Gravity seems to be the primary language it speaks. And gravity, compared to other forces, is surprisingly weak. This makes dark matter feel almost ghost-like. Present, massive, influential, yet strangely detached from everything familiar. Some theories suggest dark matter could form invisible stars. The universe has inspired extraordinary ideas. One of the most fascinating proposes the existence of dark stars. Not stars made of ordinary matter, but hypothetical objects powered partly by dark matter interactions. In the early universe, dense concentrations of dark matter may have influenced the formation of unusual stellar objects. Some models suggest these stars could have grown enormous, far larger than most stars alive today. Whether such objects truly existed remains uncertain. Yet the idea highlights something important. Dark matter may not merely shape galaxies. Under the right conditions, it might create entirely unfamiliar cosmic phenomena. A hidden astrophysics waiting to be discovered. The search for dark matter spans the entire planet. Scientists across dozens of countries contribute to the effort. Massive particle accelerators, underground detectors, space telescopes, supercomputer simulations. Thousands of researchers working toward a common goal. Few mysteries unite so many fields. Astronomy, physics, cosmology, mathematics, engineering, all converge on the same question. What is dark matter? The answer remains elusive, but every observation narrows the possibilities. Every experiment teaches something new. Even failures provide valuable clues. Science often advances this way. Not through sudden revelations, but through patient elimination, one possibility after another, until only the truth remains. Dark matter reminds us how much remains unknown. Humanity has mapped the oceans, explored the atmosphere, walked on the moon, sent spacecraft beyond the outer planets. Yet most matter in the universe may still be unidentified. There is something humbling about that realization. We often imagine ourselves living in an age where the great mysteries have been solved. Yet dark matter stands quietly in the background, a reminder that enormous questions remain. The universe is not finished surprising us, and perhaps it never will be. As you continue relaxing and letting your thoughts drift, imagine the invisible cosmos surrounding the visible one. Dark matter halos stretching beyond galaxies. Invisible filaments connecting clusters. Ancient structures guiding the formation of stars. Hidden rivers of matter flowing through the universe. Every galaxy glowing like a lantern suspended inside an unseen framework. A framework older than stars. Older than planets. Older than life itself. And somewhere within that immense darkness lies an answer. Waiting patiently. Waiting quietly. For the day when curiosity finally catches up with mystery. Until then, dark matter remains one of the universe's most beautiful secrets. Invisible, silent, everywhere, and still unknown. Imagine, for a moment, that dark matter suddenly became visible. Not forever, just for a single night. The sky would transform into something almost unimaginable. The bright stars would still shine. The planets would still wander across the heavens. The Milky Way would still stretch overhead like a river of light. But surrounding everything would be vast invisible structures finally revealed. Enormous halos would surround every galaxy. Immense filaments would connect clusters across the cosmos. The empty spaces between galaxies would no longer appear empty. Instead, they would glow with hidden architecture. The universe would suddenly seem far more crowded, far more complex, and far more beautiful. What appears today as isolated islands of light would be revealed as part of a gigantic interconnected network. A cosmic ecosystem hidden in plain sight. The universe may be floating inside an ocean of dark matter. When we picture space, we often imagine emptiness. Vast regions of nothingness separating stars and galaxies. But according to modern cosmology, truly empty space is surprisingly rare. Dark matter appears to permeate enormous regions of the universe. Galaxies move through it, clusters move through it, entire cosmic structures drift through this invisible medium. In some ways, visible matter may resemble fish swimming through an unseen ocean. The fish are easy to observe. The water is much harder. Yet the water influences everything. The movements, the currents, the behavior of entire ecosystems. Dark matter may play a similar role on cosmic scales, quietly shaping the universe without revealing itself directly. Some dark matter particles may have existed since the beginning of time. Many of the particles making up your body have remarkable histories. Some formed inside stars. Others emerged during ancient supernova explosions. But dark matter particles, if they exist, may be even older. Some theories suggest they originated during the earliest fractions of a second after the Big Bang. Before stars, before galaxies, before atoms, they may be among the oldest surviving entities in existence, traveling through cosmic history almost unchanged. If true, every dark matter particle would be a messenger from the dawn of time. An ancient traveler carrying information from the universe's first moments. A relic older than any star in the sky. Dark matter may help determine the fate of galaxies. Galaxies are delicate structures. Stars move continuously. Gas flows between regions. Black holes influence their surroundings. Without sufficient gravity, galaxies could gradually lose material. Stars might drift away. Structures could unravel. Dark matter appears to provide additional stability. Its gravity helps hold galaxies together, keeps stars bound, supports structures over billions of years. In a sense, dark matter acts like invisible glue. Not glue in the ordinary sense, but gravitational glue, a hidden force helping maintain order amid cosmic motion. Without it, many galaxies might never have survived long enough to become what they are today. The largest dark matter halos contain thousands of galaxies. Some galaxy clusters are astonishingly massive, containing hundreds or even thousands of galaxies. Each galaxy contains billions of stars. and surrounding the entire cluster may be a single gigantic dark matter halo. The scale becomes difficult to imagine. One invisible structure, thousands of galaxies, trillions upon trillions of stars, all bound together by gravity. These colossal halos rank among the largest known structures in the universe. Invisible giants stretching across millions of light years. Their existence reminds us that the most important structures in the cosmos may not be the brightest ones. Sometimes the hidden foundations matter most. Scientists can map dark matter without seeing it. This sounds almost impossible. How can you map something invisible? The answer lies in gravity. Gravity leaves fingerprints. It bends light, influences motion, shapes cosmic structures. By carefully measuring these effects, astronomers create detailed maps showing where dark matter appears to be concentrated. These maps reveal enormous halos surrounding galaxies, filaments connecting clusters, regions rich in hidden mass. The process resembles mapping wind by watching clouds. You never see the wind directly, yet its influence becomes unmistakable. Dark matter behaves similarly, invisible itself, visible through consequences. Dark matter may have helped create our solar system indirectly. The Sun formed roughly 4.6 billion years ago. Long before that, dark matter helped shape the Milky Way. The Milky Way shaped giant clouds of gas. Those clouds produced stars. One of those stars became our Sun. Around that star formed Earth. And eventually life. Dark matter did not create Earth directly, but it may have helped create the conditions necessary for everything that followed. In that sense, dark matter's story and humanity's story may be connected. Separated by billions of years, yet linked through cosmic history. The atoms in your body owe their existence to stars. And those stars may owe part of their existence to dark matter. The mystery extends beyond our galaxy. The evidence for dark matter appears almost everywhere astronomers look. Spiral galaxies, elliptical galaxies, galaxy clusters, cosmic background radiation, large-scale structure. Independent observations repeatedly point toward the same conclusion. Something invisible contributes enormous amounts of mass to the universe. This consistency makes dark matter particularly compelling. One mystery can sometimes be dismissed. Many independent mysteries pointing toward the same answer are much harder to ignore. The universe seems to be telling the same story repeatedly. A story involving hidden matter, invisible gravity, and structures beyond ordinary perception. Some physicists hope particle accelerators will find dark matter. Deep underground detectors are not the only tools in the search. Particle accelerators such as Large Hadron Collider explore another possibility. If dark matter particles can be created in high-energy collisions, scientists might detect their signatures. Perhaps not directly, but indirectly. A missing amount of energy. An unusual pattern. A subtle clue hidden among trillions of collisions. So far, no definitive discovery has emerged. Yet each experiment helps narrow the possibilities. Eliminating theories, refining models, bringing researchers one step closer. Science often progresses like a sculptor removing stone. The final shape appears gradually, one careful cut at a time. Dark matter may not be alone. Some theories propose entire hidden sectors of reality. Not merely one dark matter particle, but families of particles, hidden forces, complex invisible physics, a shadow universe existing alongside the visible one. Most of these ideas remain speculative, yet they reveal how profound the mystery has become. Once scientists accepted that most matter appears invisible, new possibilities emerged. Perhaps dark matter is not a single thing. Perhaps it is an entire unseen world, governed by rules we have barely begun to imagine. The truth remains unknown, but the possibilities are extraordinary. Every answer seems to open even larger questions. The universe remains patient. Human civilization has existed for only a tiny fraction of cosmic history. Modern astronomy is younger still. Dark matter may seem frustrating because it refuses to reveal itself. Yet from another perspective, perhaps we are simply early in the story. The universe has had nearly 14 billion years to develop its mysteries. We have been searching seriously for only a few decades. Perhaps discovery requires patience. Perhaps understanding arrives slowly. One observation, one experiment, one generation at a time. Science is a long conversation with reality. And dark matter remains one of its most intriguing unanswered questions. As the night grows deeper, imagine yourself floating far beyond the Milky Way. Far beyond the nearest galaxies. Drifting through the cosmic web. Invisible filaments stretching in every direction. Galaxy clusters glowing like distant lanterns. Dark matter forming vast hidden structures beneath everything. Silent rivers of gravity flowing through the darkness. Ancient frameworks older than stars. Older than planets. Older than life. The visible universe shining softly upon an invisible foundation. And somewhere within that foundation lies a secret. A secret that has shaped galaxies for billions of years. A secret still waiting to be fully understood. For now, it remains hidden. Quiet, patient, and endlessly fascinating.